All right, so we're going to start with the proofs of, excuse me, we're going to start with the proofs of the two special right triangles that you guys should remember from Math 2. But if you don't, that's kind of what this video is for. So the first is an isosceles right triangle. Let me move my focuser. There we go, that's better. There, it looks much better. So draw and label the isosceles right triangle. So let's first draw it. Let's look at, okay, what does that look like? Isosceles means two sides that are the same. Right, of course, means it has a right angle. All right, so we're going to review some labeling conventions here. We'll go ahead and add in the fact that they're both the same. Those little tick marks, that's exactly what that means. All right, and then we need names. So we'll call this one a leg. I know, real creative, right? Leg. And then because this has the mark here, meaning it's the same length, it's congruent, we're also going to call this one leg, right? So what do we call this? Well, it is the longest side. How do we know that? It's across from the right angle. The largest angle opens up to the largest side. So that should make pretty good sense. We'll just call it the hypotenuse. All right. So how do we get what each side is compared to the hypotenuse, right? Because we obviously know these are both the same. You know, if I was using letters, I could use the same letter for those, like X or whatever. But I chose to use leg because I'm going to use that terminology as we move into the other proof. So what if I were to tell you we could just do the Pythagorean theorem with this triangle? What would it look like? Well, the Pythagorean theorem, a squared plus b squared is c squared, where c is always the hypotenuse, would look a little something like this. Leg squared plus leg squared equals hypotenuse squared, right? And then we notice, well, hey, both of those legs are the same. Those are like terms. So I could make that 2 times leg squared equals a hypotenuse squared. So what would I have to do to then solve for the hypotenuse so that I could talk about how long the hypotenuse was in terms of legs? How much longer or shorter? No, it's not shorter. Is it, right? So what I'd actually have to do is solve for hypotenuse. How would I do that? Well, it's being squared, so we'll find the square root. All right, so what happens there, we can focus on that. The hypotenuse is now isolated. So what is that equal to? Well, we know that the property of the radical states, hey, if two things are multiplying inside, I can change that and really just take the square root of each of them individually. So the square root of 2, that's not going anywhere. Square root of 2 is irrational, so that's the best way to write it. But the square root of leg squared is just leg. So where does this get us? This means that the hypotenuse is the same length, that's what equals means. The hypotenuse is equivalent to the leg times the square root of 2. All right, so how you're going to see that moving forward is in ratio format. What I mean by that is that our two equal sides are in a 1-to-1 ratio. They're the same. And the hypotenuse is the leg, 1, times the square root of 2. Most people just leave out the 1. I like to put it in there to remind myself, hey, that's actually how you can find that side. You take a short one of the legs and multiply it by square root of 2. Okay? One thing I forgot to point out, and I want to make sure I don't forget before moving on, is that if this is isosceles, it has two equal sides, and it's right, has a right angle. But the thing about isosceles triangles is that if they have two equal sides, they automatically have two equal angles. And because both of these angles are the same, and all three angles have to add up to 180 degrees, if here's 90 of it, and both of these are the same, then of course both of those have to be 45 degrees. So some people don't call it the isosceles right triangle, they just say 45, 45, 90. And you'll hear me say that in class some. 45, 45, 90, right? Always refers to this special right triangle. So this is the first of two, right? And this is the image you want to be able to draw at the top of your paper if you're one of those people who has like a brain fart. Every time you start a quiz, write down stuff you know. And this is one of those things you want to make sure you remember, okay? All right. The second reference triangle is going to start out, right? It's a right triangle, right? And that's all you did in Math 2 is right triangles. So we know that that's 90. And we're going to fill in some other information. We're going to go ahead and say, okay, if I know that this is a 30, 60, 90 triangle, right? And that should make sense. 30 plus 60 plus 90, that adds up to 180, like it's supposed to. All right, zoom in a little bit. Then we should also, let me drop this just a tad. All right, there we go, that's better. So, what do we know about this? We don't know much of anything about this, right? We know that this is going to be the hypotenuse, it's going to be the longest side. I'm going to choose some different letters here. But even before I do that, what I want to do is extend this picture. I want to extend this picture. I want to create a congruent triangle on the other side. How will I make sure that it's congruent? Well, I'm going to use something called the hypotenuse leg congruence theorem, which you may remember. It's going to be a right triangle, which means it has a hypotenuse. Right, that's going to be the same length here. And if it's congruent, it's going to have all the same angles. All right, so here's what I've got. Yeah, it's a congruent triangle, right? So here's what we're going to do. I'm going to call this side S, meaning side. Sure, side length. We want to figure out how we can talk about that in a little bit more detail. So if that's S, then of course that would make all of these S, right? And where would we go from here? Well, how do we know that that is S? Well, let's first think about something. What type of triangle have I drawn altogether? 60, 60, 60. That's called equilateral as a result of equiangular. All the angles being the same. So 60 degrees here, here, and here means all three sides are going to be the same. So that's why I chose the letter S, right? What else does that now mean? Well, if these are indeed congruent triangles to each other by the hypotenuse leg theorem or you know, any other one you want to do, we can talk about that in math too, then that means that this side, let's get the, here we go, orange. That means this side is equal to this side. Focus a little bit. That means those two sides are equal, which means this is the midpoint. And if that's the midpoint, it is the midpoint of S, meaning each of these is going to be equal to S divided by 2. Right? Yeah. Okay. So now, if that's the case, if you understand that this is S, so this is half, each of those is half the S to make up the whole, then all we've got to do is figure out what that side is. You could call it the altitude or the height of the triangle. So we're going to engage our friend Pythagorean theorem again. All right, so, but we're going to do it, let's highlight this triangle that we're only going to work with this one. Now that we've got two of the sides in terms of S, right? So what I'm going to do, I've got S squared, which is my hypotenuse. That's like my C. That should be equal to S over 2 squared plus, let's call that H squared. All right, here's what we're going to do. We're going to define H, which is here. We're going to define H in terms of S's. All right, so what does that look like? Well, let's start squaring some stuff and see what happens. So S squared equals S squared over 4, right? You square both of those, plus H squared. Or if we combine all our S's on the one side, right, I have 1 total, subtract 1/4. 3S squared over 4 equals H squared. Again, understand I'm just subtracting S squared over 4 to the left side. All right, trying to keep it in focus. All right, and then I want to solve for H. Well, it's being square rooted, so let's engage our square root. Right, of course, what this really means is the square root of 3S squared over the square root of 4. Right, I can take the square root of 4. Hey, I know it. So we're going to replace that with a 2. I can also take the square root of the S squared, if my camera will focus, and I can get an S outside. So what does that mean H is equal to? That means H is equivalent to S divided by 2. Hey, that looks familiar. I saw that. That's actually the bottom side of the triangle. Times the square root of 3. All right, so what we've done is basically show ourselves a way that we can remember how to prove that the sides of any 30, 60, 90 triangle are in the ratio of 1 to 2 to square root of 3. And here's what I mean by that. Again, if I redraw another one, now that we've figured out what H is in terms of S, we have our S's. So this was S, recall. This is exactly half of that, right? And here's our 60-degree angle, and here's our 30. All right, so it makes sense that across from the 30 is the shortest side, S over 2. And the longest side is across from the 90. And then this was S over 2 times the square root of 3. So here's how we're going to remember that in our class. We're going to call this the short leg, right? Leg square root of 3, and 2 leg, right? I think see if that makes sense to you. If I multiply this by 2, don't I get s? If I multiply this by the square root of 3, don't I get that? All right, and one final way, which is probably what more of you purists are going to like, the ratios, just the numbers, if you will, 1, 2, and square root of 3. Making sure you realize, hey, the 30 degrees has to be here. You don't have to draw it to scale, but it does need to be close. So again, that's what I'm looking at. If I double 1, I get 2. If I double leg, I get 2 leg. Right? So those are our special right triangles. We're going to try and solve some problems with those. All right, so in the midst of that, oh, look, they're on the back. How convenient. So let's take a look then at these fill in the blank things. I don't know why I do these. Well, I do know why. I want to make sure you're paying attention, but hopefully you're paying attention. It's a video. So we've got notice the sides and angles across from those sides. Ratios is an important word because we are reviewing trigonometry. Okay, the ratios will always hold true for any triangles that have those angles. So what that means is, hey, what if this happened to be 10? Well, that would mean this would be 20, and this would be 10 times the square root of 3. Or for the isosceles triangle, if this happens to be 27, then if this is in a 1-to-1 ratio, then this is also 27. And remember that little 1 that I drew out there? This is going to be 27 times the square root of 2. Right? Remember our little leg square root of 2 trick. Right? So all of those hold their ratios from the front side. So you want to be able to draw those at will. Right? But what we're going to do here, any pair of triangles with the same angles is automatically similar. All right? Remember similar triangles. We can use this fact to determine measures of sides based purely on ratios, or otherwise known as scale factors of the triangles and their proportions from side to side. So we're going to take a look at what that means here below. First, it says examine the triangles, fill in the missing sides. So can we figure out what type of triangle this is just by looking at it? We should be able to because it's isosceles and right. It has to be one of the 45, 45, 90. So let me remind you of our trick, 1 to 1 and 1 square root of 2. So what has replaced the 1's here? The 5. So here's what we're going to do. If I don't know this, you can do it with the Pythagorean theorem, but we're going to skip that part. That would be the middle school approach. What we're going to do, we're going to say the 1 compares to the 5. This 1 compares to this 5 the same way that 1 square root of 2 should compare to, let's call it h. Right? Remember, that's a proportion. We're setting a proportion to show that the sides are going to correspond in the same ratio. So 1 is to 5. Basically, this triangle was scaled up by 5, our reference triangle from above. So all we're going to do is cross multiply to show the same relationship here, that the hypotenuse is just going to be scaled up by 5. 1 times h is h. 5 times 1 square root of 2 is 5 square root of 2. And that's really how this works. Okay? Another triangle. All right, zoom in a little bit. Take a look at that one a little closer. No pun intended. 60, 90, that means the remainder has to be 30 due to the angle sum rule of a triangle. Now, what have they given us? They've given us the leg. Right? If I draw this triangle for us up here to the right, and we know that's the leg, we know that's 2 leg, and we know this is leg square root of 3. Then, what can we do with that? How will that help us? Well, if 10 ends up being the leg, then I know that the hypotenuse is exactly double that. So this has got to be 20, and this has got to be 10 times the square root of 3. Again, all I did was get that from leg times square root of 3 using this rule. Right now, could we have done that with proportions the same way we did last time? Absolutely. Here's our 1, our 2, and our square root of 3. So zoom out a little bit. What we're going to do, we're going to say 1 compares to 10 the same way that the square root of 3 should compare to, we'll call this one x, to x, right? And how do you solve a proportion? You just cross multiply. So that's x equals 10 square root of 3. Right, so that's how this should work. What I'd like for you to do is take a second and try these 3 at the bottom. See if you can figure those out. Then we'll come back together and we'll check over your answers. All right, so if we take a brief look at the answers here, what I've done is make sure we recognize this is a square. It has to be a square if we know these two sides. It can't be a rectangle because those sides are adjacent to each other as our 4 right angles, so we know that's got to be 6. You know, you can even fill in the 6 here. So what that means is this is going to be a 30, 60, 90 triangle where the long leg is 6. So that's equal to leg times the square root of 3, right? If 6 is equivalent to leg square root of 3, then if we divide by the square root of 3, we're going to get the leg by itself, right? And it's not generally acceptable to leave a radical on the bottom, but we haven't talked about that or reviewed that yet, so we're going to leave that for today. And that should make sense to you, because to go up, we're going to multiply by square root of 3. If we're going to go backwards, go down to a shorter side, it makes sense. We're going to divide by square root of 3. And then, of course, to get a, we just double our leg value. So if you double 6 over square root of 3, you're going to get 12 over square root of 3, right? All right. Number 8, again, this is a square. How do we know? We know that this triangle is congruent to this triangle, it's congruent to this triangle, it's congruent to this triangle. 4 congruent triangles, all of which have a right angle and are isosceles. So that means this is 45 and all of the other acute angles here. Therefore, CPCTC, you might remember, corresponding parts of congruent triangles are congruent. So all these are going to be 24. So that made D pretty easy, right? But if that's true, this is the triangle that we're looking at. 24 and our right angle. All right, so if we know that this is the hypotenuse and it is the result of leg times square root of 2, right? So if leg square root of 2 is equal to 24, then I'm just going to divide to go backwards to the leg. So that's why we got 24 divided by the square root of 2 there. All right, that should make sense. Again, we're multiplying by square root of 2 to go up to the 24, so I'll divide by square root of 2 to go down. All right, and the last one. All right, this one could get tricky if you got held up on the picture, right? But it's a 30, 90, that remainder, of course, has to be 60. And then the little piece here is what's remaining to get the 105, the 45. So I've got 45, this is 90, do it to being a linear pair, and then this one's also going to be, come on, focus. This one's also going to be 45 down here. 45, 45, 90 means it's isosceles and right, meaning 8 and G are the same. Okay, check. And if that's true, 8 times square root of 2 will get me the H, which is why we got that here. So the last part we have to find is, well, what's F? Well, they told us that this was 16, that hypotenuse of that triangle. Wow, having a whole bunch of trouble being zoomed in here. So that meant that was 8. And then to go to F, all I've got to do is scale that short leg up by the square root of 3. So this is just 8 times the square root of 3. All right, good luck. Watch the other video to kind of refresh yourselves on trig and their ratios and how they're going to be used, because we'll go far past that here in Math 3.